Hi, I'm Tom, and in this video I'm going to outline my plan to try and use some light sensors to measure solar heat gain in my office. Since I can't work on my radiator sensors at this time of the year, I thought it might be interesting to use some other sensors to try and get a handle on the solar heat gain I experience in my office during the summer. In a nutshell, I want to see if there's any relationship between the light levels in my office and the temperature. Although with the UK summer off to a pretty terrible start, I'm not sure how many sunny days I'll actually get for this experiment.
God, it's lovely out.
So let's start with defining what solar heat gain actually is. Solar heat gain is defined as an increase in temperature of a space caused by the sun's rays. In a typical house, this is usually associated with the sun shining in through a window, and it's typically why the brighter rooms in your house are usually warmer than the darker ones. It's also, I believe, one of the reasons that TRVs were created, as they were designed to stop a room from overheating due to solar gain. Now, when I'm sat here working in my office, it's pretty evident to me that this room gets quite warm on a really sunny day. Like all good home heating enthusiasts, I monitor the climate in my home room by room, so I can tell you exactly how warm this room gets on a really sunny day. If we take a few days from last week, when it was actually quite sunny, you can see how the temperature starts to rise around 6 a.m. every morning. Now, my office is easterly facing, and at around 6 a.m. or 6:30 a.m. the sun will come up above the houses across the street and start to shine in through the window. And that is solar heat gain in action. So what's the plan for this little experiment? Well, in addition to recording the temperature, I'm going to start measuring the light level and the light composition in my office. Then, by comparing the light levels to the temperature, I can hopefully get an idea of how much heat is actually coming from the sun at any point in time. Once I have a handle on the solar heat gain, I can feed that into my radiator control system, which can then adjust my radiator's output in response to the sun's heat. In addition to measuring the temperature and the light, I'm hoping to also take the heat generated by my body into account. I can't do that directly, so I'm planning on using a presence sensor to act as a simple proxy. When I'm in the room, assume there's about 100 watts of heat coming from me. When I'm not in the room, no heat. I also want to try and factor in the heat coming out of the back of my PC, but at this point in time I really have no idea how I'd go about that. So what am I going to use to take the measurements? I already have temperature sensors, like this one on the wall, so that's covered. My newly installed Seed presence sensor will record when I'm in the office, if I can get the damn thing to work properly, and that just leaves the light measurement. For that, I'm going to use two different sensors. The first is a BH1750 light level sensor. This is a simple sensor that will give me the light level in lux. The second sensor is a TCS 34725. This sensor is slightly more complicated, so not only will it give me the light level in lux, it will also give me the composition of the light, that's the percentage of red, green and blue, and it will also tell me the temperature of the light in Kelvin. These sensors will be hooked up to an ESP32C3, and I will run ESP Home to read the values from each sensor and send it to Home Assistant. Home Assistant will then take those measurements and log them to InfluxDB for future analysis, and it's at that point, maybe after a couple of weeks of relatively sunny weather, that I'll be able to see if there's a relationship between the light and its composition and the temperature. Let's now take a look at the hardware I'm going to use. I've mounted it all on a breadboard for now, so it's a little untidy, but all the bits are hooked together and working nicely. The two light sensors used I2C digital protocol, which means there wasn't much I needed to do beyond hooking them up to ESP Home, which takes care of the rest. As I'm already monitoring CO2 in my office using an EE895, which uses I2C already, I just needed to add connections to the two new light sensors. This is the BH1750 and this is the TCS 34725. I2C devices can be daisy chained, so it was just a case of connecting the signal lines to the existing EE895 and then just providing them with power. I then updated the ESP Home script, adding in the new sensors. And once I powered it all up, the sensors appeared in Home Assistant. I'm now going to leave the breadboard sitting on the corner of my desk, and I'll leave it there for a couple of weeks. Once I've had a couple of sunny days and some nice changes in temperature due to solar heat gain, I'll start looking at the data and hopefully I'll be able to see some sort of relationship between all the light data and the temperature measurements. I'll do a follow-up video once I've kind of analysed it and I've got some actual results. So I'll wrap up there. If you've enjoyed this video or found it interesting, please do click that like button. That will help YouTube know that you've enjoyed the video and will hopefully then promote my videos to a wider audience. If you've any questions at all, please reach out to me using the comments. If you don't want to miss the results video, please consider subscribing, and that way then you can get alerted when I do finally publish that video in a couple of weeks. Otherwise, that's it. I'm Tom, and thanks for watching.